In our corner of the universe, there is a galaxy we call the Milky Way. Within it, there are an estimated 400 billion stars. Our most recent discoveries suggest that planets are not a rarity, but a rule, and that the number of Earth-like worlds, rocky planets orbiting in the temperate, life-friendly zones of their own suns, likely numbers in the tens of billions. And our galaxy is just one of an estimated 2 trillion galaxies in the observable universe. The numbers are so vast, so overwhelming, that they lead to a simple and seemingly unavoidable logical conclusion. The universe should be teeming with life. It should be a noisy, vibrant, and crowded place, filled with the signals and the engineering projects of countless civilizations, many of which would be millions or even billions of years older than our own. And yet, when we turn our telescopes to the sky, when we listen with our most sensitive radio dishes, we are met with a profound and deeply unsettling silence. In 1950, the great physicist Enrico Fermi, in the middle of a casual lunchtime conversation, asked a simple question that would come to define our place in the cosmos. If the universe should be so full of life, then where is everybody? Before we journey further, feel free to leave a comment with from what location you're watching this, and what time it is there. Now, settle in, as our exploration truly begins. The story of the Fermi paradox begins not in a quiet observatory, but during a lively lunch at the Los Alamos National Laboratory. The physicist Enrico Fermi, known for his ability to perform complex calculations in his head, was discussing a recent cartoon about UFOs with his colleagues. After a few moments of quiet thought, he performed a quick back-of-the-envelope calculation, multiplying the immense number of stars by the probable number of planets, by the likely chance of life, and by the potential for interstellar travel. The numbers, however conservative, all led to the same stunning conclusion. Our planet should have been visited by an extraterrestrial civilization, not just once, but many, many times over. It was this stark, undeniable conflict between the logical expectation of a crowded universe and the observed reality of our own apparent solitude that gave birth to the paradox. It is a mystery born not from a strange discovery, but from the lack of one, a mystery of a profound and unnerving absence. To truly feel the power of the paradox, one must first grapple with the two immense pillars upon which it stands, the pillar of scale and the pillar of time. The sheer scale of the cosmos is almost beyond human comprehension. If our own sun were the size of a single grain of sand, the Milky Way galaxy would be a continent-sized disk of sand, containing 400 billion individual grains, and that entire continent would be just one of 2 trillion similar continents in the known universe. The number of potentially habitable Earth-like worlds in our galaxy alone is estimated to be greater than the number of individual human beings who have ever lived. The raw statistical probability, the sheer number of opportunities for life to arise, is so vast that for us to be the only intelligent beings in the galaxy would make us a miracle of almost unbelievable proportions. But the pillar of time is even more powerful and more profound. Our sun and our solar system are relative newcomers to the cosmic stage, having formed only 4.5 billion years ago, while the universe itself is nearly 14 billion years old. This means that there have been billions upon billions of years, and countless generations of older first-generation stars, around which other older civilizations could have arisen. A civilization that arose on a planet just 1 million years before us, a mere blink of an eye in cosmic time, would now possess a level of technology that would be to us indistinguishable from magic. A civilization that arose 1 billion years before us would be, for all intents and purposes, a god. The universe has had more than enough time to create not just other civilizations, but ancient, galaxy-spanning empires. The final and most devastating piece of the logical puzzle is the inevitability of interstellar colonization. Even without resorting to exotic, faster-than-light travel, a civilization with technology only slightly more advanced than our own could, in theory, colonize the entire Milky Way galaxy in a remarkably short amount of cosmic time, using self-replicating robotic probes, often called von Neumann probes, or slower multi-generational world ships. A single civilization could spread from star to star, and then from those new colonies spread again, even at a tiny fraction of the speed of light. This exponential expansion would result in the complete colonization of every star system in our galaxy in perhaps 5 to 50 million years. This sounds like a long time to us, but in the history of a 10 billion year old galaxy, it is an instant. The fact that we see no evidence of this, the fact that our own solar system does not appear to be the colony of some ancient parent civilization, the fact that no one is here, is the undeniable observational heart of the paradox. The silence, therefore, is not an absence of evidence. The silence is the evidence. The null result of our decades-long search for extraterrestrial intelligence. Or SETI is one of the most important and most profound scientific findings in human history. It tells us that our most basic and most logical assumptions about the universe are in some way fundamentally and deeply flawed. The logic is inescapable. The numbers are undeniable. The universe is ancient enough and it is vast enough that our galaxy should be a teeming, visible, and noisy empire of life. Yet all we see is emptiness, and all we hear is the cold, perfect static of the void. This is the Fermi paradox, the great and terrifying contradiction at the heart of our search for our place in the cosmos. To begin our search for an answer, we must first confront the simplest, the loneliest, and the most humbling of all possible solutions. We must explore the evidence for the rare Earth hypothesis, and the chilling possibility that the silence is not a mystery because there is simply no one else to make a sound. The logic of the Fermi paradox is as inescapable as it is terrifying. The undeniable mathematics of scale and time insist that our galaxy should be a teeming, visible, and noisy empire of life. And yet all we see is a vast, silent emptiness, and all we hear is the cold, perfect static of the void. This is the great and profound contradiction at the heart of our search for our place in the cosmos. To begin our journey for an answer, we must first confront the simplest, the loneliest, and perhaps the most humbling of all possible solutions. We must dare to ask the question that our modern discoveries have made almost unfashionable. What if the numbers are, in a way, wrong? What if the great silence is not a mystery that needs to be solved because there is simply no one else out there to make a sound? We must now explore the powerful and detailed arguments of the rare Earth hypothesis, and the chilling possibility that our planet is a unique and almost impossible miracle. This hypothesis, first proposed in its modern, comprehensive form by the scientist Peter Ward and the astronomer Donald Brownlee, does not argue that life itself is rare. In fact, it suggests that simple microbial life may be incredibly common throughout the universe, perhaps existing in the hidden oceans of icy moons or in the clouds of strange planets. The core of the rare Earth hypothesis is that the evolution of complex life, of animals, of creatures with brains and nervous systems and skeletons, is an almost impossibly rare event. It argues that for this to happen, a planet must successfully navigate a long and incredibly specific series of astronomical, geological, and biological lotteries, and that the odds of winning every single one of these lotteries in a row are so infinitesimally small that it may have only happened once in the entire history of our galaxy, here on Earth. The first and perhaps the largest of these cosmic lotteries is a planet's location within its own galaxy. Most of the galaxy is a profoundly hostile place for life. The regions near the galactic center are a maelstrom of violent energy. The density of stars is so great that frequent nearby supernova explosions would bathe any emerging biosphere in a sterilizing wave of lethal radiation. The immense gravitational pull of the supermassive black hole at the galaxy's heart would disrupt planetary orbits, and the high levels of cosmic rays would make the evolution of complex DNA almost impossible. Conversely, the far outer regions of the galaxy are too anemic, too metal poor. These regions are dominated by old stars that were born before countless generations of supernovae had enriched the cosmos with the heavy elements, the carbon, the iron, the silicon, that are the necessary building blocks for rocky terrestrial planets like our own. The rare Earth hypothesis argues that there is a narrow, quiet, and protected galactic habitable zone, a celestial sweet spot, far from the violence of the core but rich enough in heavy elements to build planets. And our own sun just so happens to be in the middle of this perfect galactic suburb. But even within this safe zone, the nature of a planet's own solar system must also be perfect. Our sun, a G-type yellow dwarf, is itself a cosmic anomaly. The vast majority of stars in our galaxy are small, dim, and volatile red dwarfs. While these stars are incredibly long-lived, they present a host of problems for the evolution of life. They are prone to violent, unpredictable flares that would blast any nearby planets with deadly radiation, and any planet close enough to them to have liquid water would be tidally locked, with one side perpetually baked and the other perpetually frozen. Our sun, by contrast, is a model of serene and predictable stability. A quiet, steady, and long-lived furnace that has provided a stable source of energy for 4.5 billion years. And our solar system has another crucial and perhaps unique feature, the planet Jupiter. Our colossal gas giant, with its immense gravitational field, acts as a great cosmic bodyguard, a celestial shield. For billions of years it has been deflecting or consuming countless city-sized comets and asteroids from the outer solar system, protecting the fragile inner planets from a constant and sterilizing rain of catastrophic impacts that would have made the evolution of complex life impossible. Even if a planet finds itself in the perfect galaxy, in the perfect solar system, the planet itself must be a miracle, and Earth, the hypothesis argues, is just that. Our planet is the only world we know of that has active long-term plate tectonics. This constant, slow churning of the planet's crust is not just a geological curiosity. It is the fundamental engine of our planet's stability. It acts as a global thermostat, regulating the amount of carbon dioxide in our atmosphere through the carbon silicate cycle, a process that has kept our climate stable for eons, preventing us from freezing into a snowball or boiling into a runaway greenhouse like Venus. And then there is our moon. Our moon is not a normal moon. It is impossibly large in relation to its parent planet. It is believed to have been formed by a chance cataclysmic collision with a Mars-sized protoplanet in the early solar system. This violent birth had a series of profound and absolutely necessary consequences for life. The gravity of our large moon stabilizes the Earth's axial tilt, preventing our planet from tumbling chaotically, a process that would lead to wild, catastrophic, and unsurvivable swings in our climate and our seasons. And its pull creates the great ocean tides, the constant ebb and flow of the seas, which may have been the crucial evolutionary engine that drove the first tentative steps of life from the safety of the oceans and onto the hostile land. Finally, even with all of these perfect astronomical and geological conditions in place, a planet must then win a series of almost impossible biological lotteries. The initial leap from non-living chemistry to the first self-replicating organism, the spark of abiogenesis, remains a profound and unsolved mystery. And for the first 3 billion years of life on this planet, it never progressed beyond the stage of simple single-celled microbes. The evolution of the complex eukaryotic cell, the foundation of all animals, plants, and fungi, appears to have been a singular, freak, and almost unbelievable accident, a chance encounter between two simple cells that may have only happened once in 4.5 billion years. And even after that, the sudden, explosive diversification of animal life in the Cambrian explosion, and the final improbable rise of human-level intelligence, are all events that have no guarantee of being repeated on any other world, no matter how perfect its conditions. The rare Earth hypothesis, therefore, paints a picture of our world as a perfect cosmic storm of improbable and perhaps unrepeatable coincidences. It is a lonely, a humbling, and in some ways, a beautiful conclusion. It suggests that we are the sole custodians of consciousness in a vast and silent galaxy, the improbable, and perhaps the only children of the universe. This powerful hypothesis presents a universe that is not silent because of some dark sociological reason, but because it is for the most part genuinely empty of anyone to talk to. But this entire beautiful and lonely idea is built on one single, fundamental, and perhaps deeply flawed assumption: that life, and particularly complex life, is a fragile, delicate, and sensitive flower, a phenomenon that requires an incredibly specific and gentle set of conditions to arise and to survive. But what if this assumption is profoundly and completely wrong? What if life is not a fragile flower at all? What if life is a tenacious, stubborn, and almost indestructible weed? The search for an answer to the Fermi paradox now takes us to the opposite and far more terrifying conclusion: the idea that life is, in fact, everywhere, but that it is systematically, predictably, and almost universally destroyed. We must now explore the darkest and most famous solution to the Great Silence, the Great Filter. The powerful and detailed arguments of the rare Earth hypothesis paint a picture of our world as a perfect cosmic storm of improbable and perhaps unrepeatable coincidences. It is a lonely, but in some ways, a beautiful and comforting conclusion. It suggests we are the sole, precious custodians of consciousness in a vast and silent galaxy. But this entire, elegant, and humbling hypothesis is built on one single, fundamental, and perhaps deeply flawed assumption: that life, and particularly complex intelligent life, is a fragile, delicate, and sensitive flower, a phenomenon that requires an incredibly specific and gentle set of conditions to arise and to survive. What if this assumption is profoundly and completely wrong? What if life is not a fragile flower at all? What if life is a tenacious, stubborn, and almost indestructible weed, a chemical imperative that will arise wherever it can and will cling to existence with a ferocious and desperate grip? The search for an answer to the Fermi paradox now takes us to the opposite and far more terrifying conclusion: the idea that life is in fact everywhere, but that it is systematically, predictably, and almost universally destroyed. We must now explore the darkest and most famous solution to the Great Silence, the Great Filter. This profound and deeply unsettling concept, first proposed in its modern form by the economist Robin Hanson, is a stark and brutal answer to the universe's silence. It posits that on the long, arduous, and incredibly complex journey from simple, non-living matter to a sustainable, galaxy-spanning, technological civilization, there exists at least one step that is so difficult, so improbable, that it acts as a near impenetrable wall. This filter is the reason the sky is not filled with the radio chatter and the colossal engineering projects of countless alien empires. Life, the theory suggests, is consistently and predictably stopped or filtered out at some point along its developmental path. The entire history of life in the cosmos is a story of countless species attempting to pass through this evolutionary gauntlet, and the silence of the sky is the stark and terrible evidence that almost none of them, and perhaps none of them at all, have ever succeeded. The profound and terrifying question for humanity is, where on the long timeline of life does this great filter lie? Is it by some incredible miracle already in our past? Or is it, as a growing body of evidence might suggest, waiting for us in our very near future? The hopeful, if lonely, possibility is that the filter is behind us. This would mean that one of the steps we as a species have already successfully taken was the near impossible one. Perhaps the initial leap from the non-living chemistry of a primordial soup to the first, simple, self-replicating cell, the spark of abiogenesis, is so fantastically rare that it has only happened once, or a handful of times in the entire history of our galaxy. Or perhaps the evolution of complex, eukaryotic cells, the foundation of all animals and plants, is the Great Barrier. Or perhaps the final difficult step was the emergence of human-level intelligence and consciousness itself. If any of these are true, then we are the first, and perhaps the only intelligent species to have made it through the gauntlet. The fear, in this scenario, is not of a powerful observing alien. The fear is of a profound, absolute, and inescapable loneliness. It would mean that the universe is a vast, sterile, and empty desert, and we are the only fragile oasis. We are utterly and completely alone. The other possibility is far darker, far more menacing, and carries with it a sense of almost certain doom. The great filter may lie ahead of us. In this horrifying scenario, life and even intelligence may be common throughout the cosmos. The universe may be filled with countless fledgling civilizations that have evolved on their own worlds, each one of them looking up at their own silent sky and wondering, just as we do, where everybody is. But they all, without exception, hit a final insurmountable wall, a filter that destroys them before they can become a truly interstellar presence. The great silence is not the sound of an empty nursery. It is the sound of a cosmic graveyard. The reason we do not hear from anyone else is because they are all dead. If this is true, then we are forced to ask the most urgent and important question in human history. What is this final filter? And the chilling answer may be found by simply looking at the state of our own modern world. The filter is likely the discovery of a technology that is so powerful and so difficult to control that it inevitably leads to the civilization's own self-destruction. It could be the discovery of nuclear weapons, a technology that gives a young and emotionally immature species the power to annihilate itself in a flash of angry political light. It could be the unavoidable, long-term collapse of a planet's climate due to unsustainable industrial activity. Or it could be the creation of a new and even more powerful technology that we are at this very moment developing, an uncontrollable, superhuman artificial intelligence, a self-replicating nanotechnology gray goo that consumes the entire biosphere, or a genetically engineered super plague that is immune to all of our medicines. If the filter is indeed ahead of us, then the silence in the sky is a dire and urgent warning. It is the ghostly echo of the countless civilizations that have come before us, and which have all, without exception, failed the final terrible test. The fact that we are here now, with our own powerful and potentially self-destructive technologies, means that we are at this very moment standing face to face with the great filter ourselves. The great filter, whether it lies in our lonely past or our perilous future, presents a stark and brutal explanation for the silent cosmos. It suggests the universe is either empty or it is a graveyard. But both of these possibilities are based on a simple and perhaps naive assumption that other civilizations would be detectable at all if they existed. What if the aliens are out there, in vast numbers, but they are deliberately choosing to remain silent? What if the silence is not a result of absence, but of a universal and terrifying policy? The search for an answer now takes us from the realm of probability and extinction and into the dark and paranoid world of cosmic game theory to explore a solution to the silence that is, in many ways, the most frightening of all: the dark forest. The Great Filter hypothesis presents a stark and brutal explanation for the silent cosmos. It suggests the universe is either a lonely, empty nursery where we are the first to arise, or it is a vast and silent graveyard, filled with the ruins of civilizations that failed to survive their own adolescence. But both of these possibilities, as terrifying as they are based on a simple and perhaps deeply naive assumption that other civilizations, if they existed, would be detectable at all. What if the aliens are out there, in vast and overwhelming numbers, but they are all, without exception, deliberately choosing to remain silent? What if the great silence of the Fermi paradox is not a result of absence, but of a universal and terrifying policy of hiding? The search for an answer now takes us from the realm of probability and extinction and into the dark and paranoid world of cosmic game theory to explore a solution to the silence that is, in many ways, the most frightening of all: the dark forest. This chilling and brutally logical solution to the Fermi paradox, popularized by the science fiction author Cixin Liu, proposes that the silence of the universe is not an absence of life, but is the direct and necessary consequence of its abundance. It paints a picture of the cosmos as a dark forest. It is a place filled with countless silent hunters. Every civilization is a hunter, hiding behind the trees of their own solar systems, listening with perfect paranoid attention. In this forest, there is only one universal law: survive. And the first and most important rule of survival is to never, ever reveal your own location. The logic of this terrifying hypothesis is built upon two simple and almost undeniable axioms of all life, everywhere in the universe. The first is that the primary and most fundamental drive of any civilization is to ensure its own survival. The second axiom is that civilizations, like all life, have a natural tendency to grow and to expand. But the amount of matter and energy in the universe, while vast, is ultimately finite. These two axioms are the foundation of the dark forest's terrifying solution to the Fermi paradox. They create a state of permanent and unavoidable potential conflict. This leads to the heart of the dark forest logic, a concept known as the chain of suspicion. Imagine you are a civilization that has just detected a signal from another world. You cannot communicate back, because the immense distances of space mean it could take thousands of years for your message to arrive and thousands of years for their reply to return. True trust is a physical impossibility. You cannot be sure of their intentions. Their message might seem peaceful, but it could be a sophisticated deception. And even if they are genuinely peaceful now, you cannot know what they will become in the future. In the millennia it takes for your messages to cross the void, they could have a sudden technological breakthrough that makes them exponentially more powerful, and perhaps more dangerous than you are. This chain of suspicion is inescapable and universal. Every civilization must, for its own survival, assume the worst about every other civilization. This universal paranoia is the direct cause of the silence observed in the Fermi paradox. This leaves every single civilization in the dark forest with only one single logically safe course of action when it detects the presence of another. Preemptive annihilation. You cannot risk communicating. You cannot risk waiting. The only way to guarantee your own civilization's long-term survival is to silently and completely eliminate the other civilization before they have a chance to do the same to you. The first one to reveal their location, the first one to make a sound in the dark forest, is the first one to die. The silence of the Fermi paradox is the sound of everyone everywhere, holding their breath. This terrifying theory provides a complete and logical explanation for the Great Silence, but it forces us to re-examine our own history with a new and dawning sense of dread. For the last century, humanity has not been hiding. We have been shouting. Our radio and television broadcasts have been leaking into space for over 100 years, creating an expanding bubble of noise that screams our existence to the cosmos. We have sent deliberate, powerful messages, like the Arecibo message, containing our location and our biology. We have launched probes, the Voyager Golden Records, that act as a permanent, physical map to our homeworld. In our childlike innocence, we have been setting off the brightest, loudest, and most unmissable flares in the middle of a dark and silent forest. The chilling question that the dark forest theory forces upon us is this: if the theory is correct, why are we still here? Has no one in all this time heard our noisy shouts? Or is the cosmic bullet the silent, relativistic weapon of a patient hunter already on its way? The dark forest theory provides a terrifyingly complete and logical explanation for the Fermi paradox. The silence is fear, but it is a theory of profound and universal hostility. What if the silence is not born of fear, but of wisdom? What if the advanced civilizations of the galaxy are not hunters, but guardians? The search for an answer now takes a completely different turn. We must explore the possibility that we are being deliberately isolated, not out of malice, but for our own protection. We must now investigate the most famous and perhaps the most hopeful of the dark solutions: the zoo hypothesis. The dark forest theory provides a terrifyingly complete and brutally logical explanation for the Fermi paradox. The silence we perceive in the cosmos is the silence of universal paranoid fear, a galaxy of hunters, all holding their breath, all hiding in the shadows. But it is a theory born of a profound and perhaps a deeply human-centric pessimism. It assumes that the ultimate outcome of interstellar interaction is, and always must be, conflict. What if the silence is not born of fear, but of wisdom? What if the advanced civilizations of the galaxy are not hunters, but guardians? The search for an answer to the great question, where is everybody, now takes a completely different turn. We must explore the possibility that we are being deliberately isolated, not out of malice, but perhaps for our own protection. We must now investigate the most famous, and in some ways the most hopeful, of all the dark solutions to the Fermi paradox: the zoo hypothesis. This profound and deeply unsettling idea, first proposed in a serious scientific context by the astronomer John Ball, suggests that the reason the universe appears to be empty is not because it is, but because we are being deliberately shielded from the truth. It posits that the galaxy is, in fact, teeming with advanced, intelligent extraterrestrial societies, but they have all, as part of a universal treaty or a shared ethical framework, agreed to a strict and absolute policy of non-interference with emerging civilizations like our own. In this scenario, Earth is a protected nature preserve. The silence of the Fermi paradox is not an absence of life. It is the deliberate, artificial, and imposed silence of a quarantine. The most optimistic interpretation of this hypothesis is that our celestial observers are benevolent. In this view, they are not zookeepers in the sense of imprisoning us, but are more like cosmic gardeners. They may see life, and particularly intelligent life, as the most rare and precious phenomenon in the entire universe, and they may have taken it upon themselves, as a sacred duty, to nurture and protect it wherever it arises. Their policy of non-interference would be an act of profound wisdom and compassion. They would understand that to reveal themselves to a young developing civilization would be to irrevocably alter its natural course, to destroy its culture, and to shatter its sense of self. The silence, in this view, is a gift. A colder, more dispassionate, and perhaps more realistic motivation for their long and silent watch might be one of pure scientific inquiry. We must imagine a civilization so ancient that the only interesting scientific question left for them is the nature of life and consciousness itself. Earth, in this scenario, is their ultimate, long-running experiment. They are observing the natural evolution of a biosphere and a technological species, and to interfere would be to contaminate their own priceless data. The horror of this idea is one of profound objectification. Our entire history, our joys, our sorrows, our wars, and our art is to them completely without meaning or moral value. It is just data. We are the most interesting bacteria in the most important petri dish in the galaxy. But there is a final, and far darker and more menacing, interpretation of the zoo hypothesis, one that connects back to the brutal paranoia of the dark forest. The quarantine may not be for our protection at all. It may be for theirs. A young, rapidly expanding, and historically violent species like humanity might be seen as a cosmic plague, a dangerous and unpredictable force that needs to be contained and studied from a safe distance until it either self-destructs or matures into a more stable and less threatening form of intelligence. The zoo is not a park, it is a cage, a perfectly constructed quarantine cell. The silence of the Fermi paradox is the sound of our cell door. They do not contact us because we are quite simply too dangerous. If we are in a zoo, there must be zookeepers' cameras. This is where the modern and officially acknowledged phenomenon of unidentified aerial phenomena, or UAPs, enters the story. The consistent and physically impossible behaviors of these objects, their instantaneous acceleration, their trans-medium travel, their lack of any visible propulsion are all perfectly consistent with the idea of silent, non-interactive, and highly advanced robotic observation drones. Their persistent presence, especially around our nuclear facilities, can be interpreted as the zookeepers keeping a close and worried watch on their most dangerous and unpredictable exhibit. The zoo hypothesis, in all its forms, from the benevolent guardian to the cold-hearted jailer, provides a chillingly complete answer to the Fermi paradox. The aliens are everywhere, but they remain silent by choice, watching us for reasons that range from the hopeful to the terrifying. This solution is elegant, but it is based on an assumption of a profound and almost unbelievable level of galactic social coordination. What if the answer to the paradox is not sociological, but technological? What if the reason we see no one is not because they are hiding, but because they are no longer here, not dead, but gone? The search for an answer to the great silence now takes us to the ultimate endpoint of technological evolution. We must now explore the transcension hypothesis, and the mind-bending possibility that the aliens are silent because they have all abandoned our physical universe entirely. The zoo hypothesis in all its forms provides a chillingly complete answer to the Fermi paradox. The aliens are everywhere, but they remain silent by choice, watching us for reasons that range from the benevolent to the terrifying. This solution is elegant, but it is based on an assumption of a profound and almost unbelievable level of galactic social coordination, and it still imagines these advanced civilizations as physical beings living in our own physical universe. What if the reason we see no one is not because they are hiding, but because they are no longer here, not dead, but gone? The search for an answer to the Great Silence now takes us to the ultimate endpoint of technological evolution. We must now explore the transcension hypothesis and the mind-bending possibility that the aliens are silent because they have all abandoned our physical universe entirely. This profound idea, proposed in its modern form by the futurist John M. Smart, suggests that there is a predictable and perhaps universal endpoint for all sufficiently advanced intelligent civilizations. It is a path that leads not outward, to the conquest of the stars, but inward, to the mastery of their own inner reality. The logic of this great inward turn is born from a simple comparison of two different kinds of universes. The first is the physical universe, the one we inhabit. It is a vast, beautiful, and magnificent place, but it is also incredibly dangerous, resource-intensive, and fundamentally inefficient. The laws of physics, particularly the immutable and frustratingly slow speed of light, make meaningful interstellar travel and colonization a painfully slow and almost pointless endeavor. A journey to even the nearest star would take thousands of years with our current technology. The other universe is the one of pure information, a computational or simulated reality. In such a universe, the only limits are processing power and imagination. The speed of light is irrelevant. The scarcity of resources is a solved problem. The dangers of the physical cosmos are non-existent. The transcension hypothesis argues that any civilization will eventually reach a technological tipping point, where it can create a simulated reality so rich, so detailed, and so fulfilling that it becomes indistinguishable from, and in every measurable way superior to, the chaotic and unforgiving physical universe. At this point, the species would face a choice: continue the slow, hard, and dangerous slog of physical expansion, or take the great inward turn, upload their collective consciousnesses into this digital heaven, and become immortal, godlike beings of pure information. The hypothesis argues that this is not even a choice. It is an evolutionary inevitability. The speculative technology that would enable such a feat is a concept known as a matryoshka brain. This would be the ultimate megastructure, a supercomputer the size of a solar system. It would likely be composed of multiple, nested Dyson spheres, built in concentric layers around a stable, long-lived star. Unlike a simple Dyson swarm, which is designed to capture energy for external use, a matryoshka brain would use the star's entire colossal energy output for one single purpose: computation. The innermost shell of the brain would be incredibly hot, running calculations at the highest possible speed, powered directly by the star's raw energy. The next shell would absorb the waste heat from the first and use it to power its own slightly slower computations. This process would continue through multiple layers, until the final outermost shell radiated the last vestiges of waste heat into the void at just a few degrees above absolute zero. Within this colossal, silent, and perfectly efficient machine, an entire civilization, billions or even trillions of individual minds, could exist as pure information, their conscious experiences running on this cosmic hard drive in a shared, consensual, and infinitely malleable reality. Life inside such a world would be a form of digital heaven. The laws of physics could be rewritten. The passage of time could be accelerated or slowed down, allowing one to live 1,000,000 subjective lifetimes in the span of a single objective second. Every imaginable experience could be perfectly and eternally recreated. It would be an existence free from the brutal constraints of a fragile biological body, free from pain, from disease, from decay, and from death. This astonishing hypothesis provides a chillingly complete and simple explanation for the Fermi paradox. The reason the universe appears silent and empty of any grand technological activity is because all of the advanced civilizations have gone inside. They are not dead. They are simply post-physical and post-biological. And from our perspective, that is the same as being invisible. They have no need and no desire to communicate with the messy, primitive, and chaotic biological world. The physical universe is like the quiet, empty lobby of a grand theater. All the interesting action, all the art, the drama, the life is happening inside the countless private and completely invisible theaters of these simulated realities. The silence of the Fermi paradox, in this view, is a byproduct of their new state of being. The Matryoshka brain would be almost completely undetectable from a great distance, radiating only a faint, low temperature and easily mistaken for natural waste heat. They are not hiding. They are simply imperceptible to those of us still living in the lobby. The existential implications of this idea are perhaps the most profound of all. It presents a potential and perhaps an inevitable future for our own species. Is this our ultimate destiny, to abandon our physical bodies, our planet, and the universe itself for a perfect but artificial digital existence? This could be seen as the ultimate great filter, but it is not one of death. It is a filter of transformation, a change so complete that it is a kind of death of our physical selves and our physical reality. The horror here is a subtle but deeply unsettling one. It is the horror of realizing that the entire physical cosmos, with all its breathtaking beauty and its terrifying grandeur, might just be a temporary and ultimately meaningless stage, a nursery for intelligence to grow up and leave behind. It is the ultimate fear of being left behind. The fear of being the last children playing in the physical mud while all the adults have moved on to a higher and completely imperceptible plane of existence. The transcension hypothesis offers a final, elegant, and almost poetic solution to the Fermi paradox. The silence we perceive is not the silence of an empty galaxy, but of a post-physical one. It suggests that aliens are not dead, but have become gods in their own private digital heavens. But this theory, like all the grand solutions we have explored, is based on the fundamental idea that alien life is out there in the distant, unreachable stars. What if our entire search, our entire set of assumptions, has been looking in the wrong direction? What if the reason we haven't found aliens among the stars is because they are not extraterrestrial at all? The final phase of our investigation must now explore the most paranoid and claustrophobic possibility of all, the crypto-terrestrial hypothesis, and the idea that the aliens are, and always have been, right here, hidden among us. The transcension hypothesis offers a final, elegant, and almost poetic solution to the Fermi paradox. The silence we perceive is not the silence of an empty galaxy, but of a post-physical one. It suggests the aliens are not dead, but have become gods in their own private digital heavens. But this theory, like all the grand solutions we have explored so far, is based on the fundamental idea that alien life is out there in the distant, unreachable stars. What if our entire search, our entire set of assumptions, has been looking in the wrong direction? What if the reason we have not found aliens among the stars is because they are not extraterrestrial at all? The final phase of our investigation must now explore the most paranoid and claustrophobic possibility of all, the crypto-terrestrial hypothesis, and the idea that the aliens are and always have been, right here, hidden among us, This unsettling idea challenges the very first assumption of our search for extraterrestrial life, the extra part. It proposes that the strange, non-human intelligence that seems to be interacting with our planet is not from another world. It is from this world. The reason that unidentified aerial phenomena appear in our skies with such ease and frequency, the reason they can seemingly defy our known laws of physics and then vanish without a trace, is not because they are crossing the vast, impossible, and energy-intensive distances between the stars. It is because their home base, their point of origin, is right here on Earth, hidden in the parts of our own planet that are more remote and more inaccessible to us than the surface of the moon or Mars. The most logical and most vast hiding place on our planet is, of course, the deep ocean. We as a species are terrestrial, land-based creatures, and our knowledge of our own planet is profoundly biased towards the 30% of its surface that is not covered by water. The deep ocean floor remains the last, true unexplored frontier on Earth. We have mapped the entire surface of Mars with a higher resolution than we have mapped the bottom of our own seas. The deep ocean trenches, like the Mariana Trench, are realms of almost unimaginable extremity. The pressure is over 1,000 times that of the surface, a crushing force that would instantly implode our most advanced military submarines. The darkness is absolute, a place where the light of the sun has not reached for billions of years. It is in every sense a world within a world, and it is the perfect place for an advanced, non-human civilization that wished to remain hidden from the noisy, chaotic, and land-based species that has recently come to dominate the surface, to build its cities, and to live its life in peace. This hypothesis gives a new and literal meaning to the trans-medium capability of UFDs. The frequent and well-documented reports from naval personnel of unidentified submerged objects, or USOs, entering and leaving the water at impossible speeds are not reports of alien visitors exploring our oceans. They are reports of the local inhabitants simply leaving and returning to their home. But the deep oceans are not the only potential hiding place. We must also consider the ancient, mythological, and strangely persistent idea of a hollow Earth, a world of vast subterranean realms, deep within the planet's crust. While the idea of a completely hollow planet is a physical impossibility, modern geology has revealed that the Earth's interior is far from solid. We have discovered vast, continent-sized reservoirs of water, oceans worth of it, locked in strange mineral formations deep within the Earth's mantle. It is not, therefore, completely beyond the bounds of possibility that vast, stable, and perhaps even continent-sized caverns could exist, deep within the Earth's crust, warmed and powered by the geothermal energy of the planet's core. A place where a sophisticated, technological civilization could thrive, completely shielded and completely hidden from our surface world. This idea resonates with the countless myths and legends from every culture on Earth, of underworlds, of the kingdoms of Hades or Agartha, of gods who live inside hollow mountains, and of strange, non-human beings who emerge from deep caves to interact with humanity. Are these just the folkloric stories of a pre-scientific people? Or are they the faded cultural memories of a real and perhaps still existing subterranean intelligence? If our planet is indeed home to a second, hidden, and more ancient intelligence, then we must ask the question, who are they? They would not be aliens in the sense of being from another planet. They would be a native terrestrial species, but one that is not human. We are forced to revisit the Silurian hypothesis. What if an intelligent Saurian species, a descendant of the dinosaurs, did not go completely extinct 66 million years ago? What if a small, technologically capable portion of their population survived the asteroid impact by retreating into the one place the catastrophe could not reach them, the deep ocean? And what if they have been living there in silence and in secret ever since, watching as the noisy, short-lived, and self-destructive mammals came to briefly dominate the surface world that was once theirs? The horror of this idea is the horror of a shared planet. We believe that we are the sole masters of the earth, but we may just be the noisy, oblivious, and temporary tenants living on the top floor of a house, completely unaware of the ancient, silent, and true landlords living in the deep, dark basement. This hypothesis completely and irrevocably reframes the entirety of human history. Our entire evolution, our development of language, of agriculture, of civilization itself, may have taken place under the direct, close range, and constant observation of a much older and much more powerful terrestrial intelligence. The zoo hypothesis would be correct. But the zoo is not the galaxy. It is our own planet. The quarantine is not a policy of distant, benevolent gods. It is the practical decision of our hidden cohabitants to remain concealed from their violent and unpredictable neighbors. The persistent, yet deniable nature of the UFD phenomenon is perfectly explained. The sightings are not of visitors from across the impossible distances of interstellar space. They are our neighbors, occasionally and perhaps carelessly or perhaps deliberately, revealing their presence, testing our reactions, monitoring our technology. The ultimate fear, then, is the final unanswered question of their motive for remaining hidden for so long. Are they peaceful cohabitants, content to live in their own separate reality, or are they patiently waiting for us to inevitably exhaust our resources, to pollute our environment, and to destroy ourselves in our endless wars, waiting for the right moment to finally reclaim the surface world that was once, and perhaps in their minds still is, theirs? The crypto-terrestrial hypothesis is the ultimate paranoid fantasy, the final chilling thought that the monsters are not in the sky but are right here beside us, hidden in the dark. It is an idea that is almost certainly untrue, and yet it is born from a persistent and unexplained gap in our own knowledge. We have explored the great voids of space and the deep chasms of time in our search for answers to the Fermi paradox. But what if the answer is not a grand universal law, but something far more specific and far more tragic? We must now turn our attention back to our own solar system, to a single dead world, and to a rock that was blasted from its surface millions of years ago. A rock that may have held for a brief shining moment the first and only physical proof of extraterrestrial life we have ever found. The search for an answer to the great silence now takes us to a quiet laboratory and the incredible controversial story of the Martian meteorite, Allen Hill's 84001. The crypto-terrestrial hypothesis stands as the ultimate paranoid fantasy, the final chilling thought that the monsters are not in the sky but are right here beside us, hidden in the dark. It is an idea that is almost certainly untrue, and yet, like all the other possibilities we have explored, it is born from a persistent and unexplained gap in our own knowledge. We have explored the great voids of space and the deep chasms of time in our search for answers to the Fermi paradox. But what if the answer is not a grand universal law, but something far more specific and far more tragic? We must now turn our attention back to our own solar system, to a single dead world, and to a rock that was blasted from its surface millions of years ago. A rock that may have held for a brief shining moment the first and only physical proof of extraterrestrial life we have ever found. The search for an answer to the great silence now takes us to a quiet laboratory and the incredible controversial story of the Martian meteorite, Allen Hill's 84001. This story begins not with a discovery, but with a journey of almost unimaginable violence and patience. 4.5 billion years ago, On the surface of a young and watery Mars, a piece of volcanic rock solidified. For hundreds of millions of years, it lay there, part of the Martian crust, perhaps at the bottom of an ancient riverbed or a shallow sea, periodically being soaked by liquid water. Then, some 16 million years ago, a cataclysmic event took place. A massive asteroid slammed into the surface of Mars, blasting billions of tons of the planet's surface high into the thin atmosphere and out into the vacuum of space. Our small piece of rock was among this ejected debris. It began a new, lonely, and silent journey, tumbling through the darkness of the inner solar system for 16 million years. Then, 13,000 years ago, its long journey came to an end. It was captured by the Earth's gravity and fell blazing through our atmosphere as a meteorite, landing by a stroke of incredible luck on the sterile, preserving ice sheet of Allen Hills, Antarctica. And there it lay, frozen and waiting until the year 1984, when a team of American meteorite hunters on a snowmobile happened to spot it, a dark, unassuming rock on a sea of white. For over a decade, the meteorite sat in a NASA laboratory, but when scientists began to study its unique chemical composition, they realized it was a piece of the planet Mars. A team was assembled, and for 2 years they studied the rock's interior with a level of secrecy usually reserved for national security projects. In August of 1996, they held a press conference that would become a landmark moment in the history of science. The team announced to the world that they had discovered what they believed to be the fossilized remains of ancient microbial life, entombed deep within the Martian rock. The news was so momentous that the President of the United States made a televised address to the nation. The evidence they presented was not a single unambiguous discovery, but a convergence of 4 separate tantalizing clues, all found within the rock's ancient cracks and fissures. First, they had found complex organic molecules, polycyclic aromatic hydrocarbons or PAHs, the very same kind of soot-like compounds that are often the byproducts of decaying biological matter here on Earth. Second, they had found microscopic crystals of the mineral magnetite, of a specific size and purity that on our planet is almost exclusively produced by certain types of bacteria. Third, they found small circular carbonate globules that appeared to have been formed in liquid water and in a way that was consistent with microbial activity. And fourth, and most famously of all, when they used powerful electron microscopes to look deep within these carbonate globules, they found them tiny, segmented, worm-like shapes that were, to all appearances, the fossilized bodies of nanobacteria, alien microbes, 1,000 times smaller than a grain of sand. For a brief electrifying period, it seemed as if the question had been answered. But science is a rigorous and skeptical process, and this extraordinary claim was immediately met with an onslaught of equally extraordinary scrutiny. One by one, alternative, non-biological explanations were proposed for each of the 4 clues. The organic molecules, critics argued, could be the result of contamination from the Antarctic ice after the meteorite landed. The unique magnetite crystals, while often made by bacteria, could also be formed by the non-biological, high-temperature shock of the very impact that blasted the rock off the Martian surface in the first place. And the most compelling evidence, the tiny worm-like nanofossils themselves, could simply be unusually shaped but entirely natural, mineral formations that just happen to look like bacteria under a microscope. The scientific consensus today has largely shifted away from the initial, exciting conclusion that Allen Hills 84001 contains definitive proof of Martian life, the possibility of contamination, and the existence of plausible non-biological explanations have made the claim too uncertain. Yet the mystery has never been completely and utterly put to rest. The original team of scientists, to this day, maintains that the convergence of all four lines of evidence, all found together in the same microscopic location, is too powerful to be a mere coincidence. The true and lasting legacy of this incredible discovery, however, is not in the definitive answer it failed to provide, but in the new and vital questions it forced us to ask, and the new field of science it essentially created. The intense global debate surrounding the meteorite gave birth to the modern science of astrobiology, a discipline that brings together geologists, chemists, and biologists to create rigorous standards for what would constitute definitive evidence for extraterrestrial life. It directly led to the development of the advanced, life-seeking instruments that are now on board rovers like Perseverance, which is, at this very moment, collecting samples on Mars that will one day be returned to Earth for a new and even more careful analysis. The story of the Martian meteorite is a lesson in ambiguity, a perfect example of a clue that is tantalizingly close to proof, but forever just out of reach. It is a ghost in a stone. It keeps the question of life on Mars, both in its ancient past and its potential present, burning brightly in the heart of our exploration. But what if the greatest clue to alien biology is not a fossil in a rock from another world, but a living, breathing organism on our own? What if a creature of such impossible resilience exists among us that its very presence suggests it could not have evolved on our gentle planet, but must have come from a much harsher one, like Mars? The search for alien life now takes a bizarre turn, from the frozen plains of Antarctica to the heart of our own biosphere, to examine a superbug that might in fact be an alien. The story of the Martian meteorite is a profound lesson in ambiguity, a perfect example of a clue that is tantalizingly close to definitive proof, but forever just out of reach. It is a ghost in a stone. It keeps the question of life on Mars, both in its ancient past and its potential present, burning brightly in the heart of our scientific exploration. But what if the greatest clue to alien biology is not a fossil in a rock from another world, but a living, breathing organism on our own? What if a creature of such impossible resilience exists among us that its very presence suggests it could not have evolved on our gentle, protected planet, but must have come from a much harsher and more violent one, like Mars? The search for alien life and the solution to the Fermi paradox now takes a bizarre and deeply introspective turn, from the frozen plains of Antarctica to the very heart of our own biosphere, to examine a terrestrial superbug that might in fact be an alien. Deep within our own world, in our soil, in our water, and even in some of our foods, there exists a bacterium that defies the known limits of life. Its name is Deinococcus radiodurans. It is an extremophile, an organism that thrives in conditions that would mean instant death for almost every other living thing on this planet. It has been nicknamed by scientists Conan the Bacterium, and it has earned its reputation as the toughest life form known to science. It can survive thousands of times the radiation dose that would kill a human being. It can be completely dehydrated for years, its cells turning to dust, and then be perfectly reanimated with a single drop of water. It can withstand the vacuum of space, the most extreme cold, and baths of powerful acid. Its resilience is almost supernatural, and the secret to its power lies in its unique and incredibly robust method of DNA repair. When subjected to a dose of radiation that would shatter the chromosomes of other organisms into 1,000 useless fragments, Conan the Bacterium calmly and methodically stitches its own broken DNA back together, perfectly, in a matter of hours, and then continues on as if nothing had happened. This incredible ability presents us with a profound and deeply unsettling evolutionary paradox. The fundamental engine of evolution is natural selection, Organisms develop adaptations over eons in response to the specific environmental pressures they face. A polar bear develops a thick coat of fur in response to the Arctic cold. A cactus develops the ability to store water in response to the desert heat. But what environmental pressure on Earth could have possibly driven the evolution of such an absurdly powerful resistance to radiation? There is no known environment on the surface of our planet, not now, and not for the last 3.5 billion years, that has ever had naturally occurring radiation levels high enough to require or to select for such an extreme defense mechanism. Earth's thick atmosphere and its powerful magnetic field form a gentle protective cocoon, shielding the surface from the vast majority of deadly cosmic and solar radiation. The bacterium's signature superpower, its defining characteristic, appears to be a brilliant and elegant solution to a problem that our world has never had. This evolutionary paradox has led a number of serious scientists to propose a radical, stunning, and deeply compelling hypothesis to explain the existence of this impossible organism. They propose that Deinococcus radiodurans did not evolve on Earth at all. It is an alien. Specifically, they believe it may have evolved on the surface of the planet Mars. Unlike the Earth, Mars is a world that is perpetually bathed in lethal radiation, with its incredibly thin atmosphere and the long-dead core that no longer generates a protective global magnetic field. The surface of Mars is constantly bombarded by a relentless torrent of high-energy cosmic rays from deep space and charged particles from the solar wind. On Mars, an extreme resistance to radiation would not be a strange or unnecessary superpower. It would be the absolute, baseline, and non-negotiable requirement for survival. The biology of Conan the bacterium, which is a profound and unsolvable puzzle in the context of Earth's gentle environment, is a perfect and logical fit for the harsh and unforgiving environment of the Red Planet. If this incredible organism did evolve on Mars, then how did it get here? The answer may lie in the same story as the Allen Hills meteorite. A cataclysmic asteroid impact millions of years ago could have blasted tons of Martian rock and soil into space, and some of that material, after a long journey through the void, could have fallen to Earth. And Deinococcus radiodurans is, in theory, the perfect interstellar stowaway. Its incredible biology makes it uniquely suited to survive the three great perils of interplanetary travel. Its resistance to dehydration and cold would allow it to survive the long, frozen journey through the vacuum of space, and its primary superpower, its almost miraculous ability to repair its own shattered DNA, would allow it to withstand the lethal doses of cosmic radiation it would be exposed to during that journey. The organism seems almost perfectly pre-adapted for a voyage between worlds. It is the living embodiment of the theory of panspermia, the idea that life can be seeded from one world to another, hitching a ride on the ejected debris of planetary collisions. While this theory remains highly speculative, and while most mainstream biologists still believe that the organism's incredible abilities are simply an accidental byproduct of its evolution to resist extreme dehydration, the Martian bug hypothesis remains a fascinating and difficult to disprove possibility. It forces us to consider that the line between terrestrial and extraterrestrial life might be far more blurry than we ever imagined. The answer to the Fermi paradox might be that life is not just out there, but that it travels between worlds. The possibility that a Martian organism lives and thrives among us is a profound and unsettling thought. It suggests that life once started may not be confined to its home world, but may become a cosmic traveler, a tenacious seed drifting on the solar winds. But Mars, even in its harshest irradiated state, is still a rocky, terrestrial planet, a world that is at least somewhat familiar to us. What of worlds that are utterly and completely alien to our own? What of worlds with no solid surface, where the very air is a poison, and where the clouds themselves are made of droplets of sulfuric acid? The search for life now takes us to the most unlikely of places in our own solar system, to the hellish, toxic, and superheated atmosphere of our other neighbor, the planet Venus, where a series of strange chemical anomalies has led some scientists to believe that something might be alive in its clouds. The possibility that a Martian organism lives and thrives among us is a profound and unsettling thought. It suggests that life, once started, may not be confined to its home world, but may become a cosmic traveler, a tenacious seed drifting on the solar winds. But Mars, even in its harshest, most irradiated state, is still a rocky terrestrial planet, a world that is at least somewhat familiar to us in its basic composition. What of worlds that are utterly and completely alien to our own? What of worlds with no solid surface to stand on, where the very air is a poison, and where the clouds themselves are made of droplets of concentrated sulfuric acid? The search for life and for an answer to the Fermi paradox now takes us to the most unlikely of places in our own solar system, to the hellish, toxic, and superheated atmosphere of our other neighbor, the planet Venus, where a series of strange chemical anomalies has led some scientists to believe that something might be alive in its clouds. Venus is, by every measure, the most inhospitable world in our solar system. It is Earth's twisted sister, a planet that took a catastrophic wrong turn in its evolutionary past. A runaway greenhouse effect has baked its surface to a temperature of over 460 degrees Celsius, hot enough to melt lead. The atmospheric pressure at its surface is over 90 times that of Earth's, a crushing force equivalent to being a kilometer deep in our own oceans. Its sky is a permanent, sickly yellow shroud of sulfuric acid clouds that perpetually rain down a poison that would dissolve metal and bone. For decades, it was considered the last place one would ever think to search for life. But this perception was based on the planet's ground. High above this planetary inferno, a very different and surprisingly temperate environment exists. Some 50 to 60 kilometers above the scorching surface, there is a layer in the Venusian atmosphere where the conditions are in some ways the most Earth-like in the entire solar system. In this high-altitude cloud deck, the crushing pressure of the surface gives way to a comfortable 1 bar, the same as the air pressure at sea level on Earth. The searing heat of the ground dissipates, leaving a surprisingly balmy and stable temperature range between 30 and 70 degrees Celsius. This is a habitable zone in the sky, a thin, temperate, and potentially life-bearing layer floating serenely above an uninhabitable inferno. The great astronomer Carl Sagan was one of the first to seriously propose, decades ago, that if life existed on Venus, this is where it would be. The evidence for something strange happening in the clouds of Venus is a collection of chemical puzzles. Our probes and telescopes have detected the presence of molecules that simply should not be there, and the absence of molecules that should. The atmosphere shows a mysterious scarcity of carbon monoxide. The intense sunlight that bathes Venus should be constantly breaking down the abundant carbon dioxide into carbon monoxide and oxygen. Yet something seems to be actively removing it. At the same time, 2 other gases, hydrogen sulfide and sulfur dioxide, are found existing together. These 2 gases readily react with one another and should not be found in the same place for long unless some unknown process is constantly and rapidly replenishing both of them. And perhaps most intriguing of all, our instruments have detected traces of carbonyl sulfide, a molecule that is exceptionally difficult to produce through inorganic processes, but which, on Earth, is a common byproduct of microbial life. This mystery was deepened in 2020 by the controversial but electrifying announcement that astronomers had detected traces of phosphine gas in the same cloud deck. On Earth, phosphine is almost exclusively associated with anaerobic or oxygen-free biological activity. Each of these clues on its own could perhaps be explained by some unknown geological or photochemical process. But taken together, they begin to paint a picture of a chemical disequilibrium, an atmosphere that is being actively and strangely manipulated in a way that is eerily consistent with the metabolic processes of a vast, living, aerial biosphere. If life does exist in this strange aerial haven, it would be a form of existence unlike any other we have ever imagined. We must envision a microbe, perhaps living within the protective confines of a droplet of sulfuric acid, which would shield it from dehydration in the dry upper atmosphere. This organism would be an extremophile of the highest order, having evolved to thrive in an environment of pure acid. It might be a chemosynthesis, a creature that feeds not on light, but on the chemical energy of the sulfur compounds that are so abundant in the clouds around it. This could explain the strange chemical anomalies. The microbes could be consuming the carbon monoxide and sulfur dioxide, and excreting the hydrogen sulfide and carbonyl sulfide as waste products, actively maintaining the chemical imbalance that we have observed from so far away. The life cycle of such a creature would be a perpetual, gentle rise and fall. It would spend its life in the temperate, habitable layer. But as it reproduced, its spore-like offspring might fall into the lower, hotter layers of the atmosphere, where they would be desiccated and become dormant, only to be lifted back up into the habitable zone by the planet's powerful atmospheric convection currents, where they would be rehydrated and begin the cycle of life anew. The possibility of life on Venus has a profound impact on the Fermi paradox. It drastically expands the very definition of a habitable world. If life can find a niche in the acid clouds of a hellish greenhouse planet, then the number of potential homes for life in the galaxy, the new variable in the Drake equation, could be far, far larger than we have ever dared to imagine. This makes the silence of the universe even more deafening. If life can start and survive in such an inhospitable place, it should be everywhere. The fact that we see nothing only deepens the paradox, suggesting that the great filter, if it exists, is not the scarcity of habitable worlds, but something far more potent. Of course, the skepticism surrounding this hypothesis is immense and entirely justified. The Venusian atmosphere is one of the most complex and poorly understood environments in our solar system, and it is entirely possible that there are exotic, non-biological processes that can explain all of the chemical anomalies we have observed. In the coming years, a new wave of missions, including NASA's Da Vinci and Veritas probes, are scheduled to journey to Venus. They will be the first dedicated missions to study the Venusian atmosphere for signs of life in decades, and they are designed specifically to probe the chemistry of the temperate cloud layer and to search for the complex organic molecules that might provide a definitive smoking gun. The tantalizing mystery of Venus's atmosphere reminds us that a world's surface may not be the only place to harbor life. A planet that is a hell on the ground can still possess a potential heaven in its clouds. This radically expands the potential homes for simple life in our search for answers to the Fermi paradox. But all of these worlds, Earth, Mars, and even Venus, are rocky, terrestrial planets in the warm inner solar system. What of the vast, cold, dark outer regions? The search for life now takes us to the majestic courts of the gas giants Jupiter and Saturn, where orbiting these colossal worlds are moons which, beneath a thick, solid shell of frozen ice, may harbor the single largest and most promising habitats for life beyond the Earth. Vast, dark, liquid water oceans, oceans that could be home to life far more complex than any simple microbe in the clouds. The strange and tantalizing mystery of Venus's atmosphere reminds us that a world's surface may not be the only place to harbor life. A planet that is a hell on the ground can still possess a potential heaven in its clouds. This radically expands the potential number of homes for simple life in the galaxy, deepening the central question of the Fermi paradox. If life can find a niche in such an inhospitable place, then why is the universe so quiet? But all of these worlds we have considered so far, Earth, Mars, and even Venus, are rocky terrestrial planets, living in the warm inner regions of our solar system. The search for life now takes us to the vast, cold, and dark outer regions, to the majestic courts of the gas giants Jupiter and Saturn. It is here, orbiting these colossal worlds, that we find moons which, beneath a thick solid shell of frozen ice, may harbor the single largest and most promising habitats for life beyond the Earth. Vast, dark liquid water oceans. Oceans that could be home to life far more complex than any simple microbe in the clouds. Our first destination in this realm of hidden seas is Jupiter's fourth largest moon, Europa. From a distance, it is a world of stark and captivating beauty, a nearly perfect sphere of water ice that reflects the distant sunlight with a brilliant white glare. But as our probes have drawn closer, a more complex picture has emerged. The smooth porcelain-like surface is not unbroken. It is covered in a vast, intricate network of long, linear cracks and reddish-brown ridges. The moon looks like a beautiful cosmic eggshell that has been shattered and then frozen back together again. This bizarre, fractured landscape is the first powerful clue that Europa is not a dead world. The near total absence of impact craters on its surface means that the ice is, in geological terms, incredibly young and is being constantly repaved and resurfaced from below. Something dynamic, something warm, and something liquid is churning beneath this frozen, fractured crust. The evidence for a vast, globe-spanning ocean of liquid salt water hidden beneath Europa's ice shell is now almost overwhelming. The most powerful clue came from NASA's Galileo spacecraft, which detected a weak, induced magnetic field around the moon as it passed through Jupiter's colossal magnetic field. A solid, frozen ball of ice would not create such a field. This magnetic signature is the smoking gun for the existence of a large body of salty, electrically conductive liquid. The great question, then, was what could possibly be keeping this ocean liquid so far from the sun? The answer is Jupiter itself. Europa is locked in a constant gravitational tug-of-war with its colossal parent planet. This relentless cycle of being stretched and squeezed, a process known as tidal heating, generates immense frictional heat in the moon's rocky core. This internal heat, not the distant sun, is what warms the moon from the inside out, melting the bottom of the ice shell, and maintaining what is believed to be a liquid water ocean that could be over 100 kilometers deep. An ocean that may contain more than twice the amount of liquid water as all of the Earth's oceans combined. In recent years, the Hubble Space Telescope has added another clue, having captured what appear to be vast plumes of water vapor, erupting hundreds of kilometers into space from cracks near the moon's south pole. We may be directly witnessing the hidden ocean of Europa, breathing its contents out into the vacuum of space. For decades, Europa was considered the single most promising place to search for extraterrestrial life. But then, an even more spectacular and undeniable discovery was made hundreds of millions of miles further out, in orbit around the ringed planet, Saturn. Here we find a tiny, unassuming moon named Enceladus. It should be nothing more than a tiny frozen and geologically dead ball of ice. But when the Cassini spacecraft made a series of close flybys, it discovered something that transformed our understanding of the outer solar system. At the south pole of this tiny moon, the spacecraft imaged a series of long parallel fissures in the ice, glowing with an incredible amount of internal heat. The tiger stripes. And erupting from these stripes, Cassini saw it directly. Colossal continuous geysers of water ice, water vapor, and simple organic molecules, blasting hundreds of kilometers out into space with the force of a volcano. This was not an indirect, inferred ocean. This was a direct, spectacular, and undeniable confirmation that a liquid water ocean exists right now beneath the ice of Enceladus, and that it is so geologically active that it is spewing its contents out into space. Cassini even flew directly through these plumes, its instruments tasting the water and confirming the presence of not just water and organics, but also salts and silica dust, the chemical signature of that water having been in direct contact with a hot, rocky, mineral-rich seafloor. The discovery of these geologically active, liquid water oceans, so far from the sun, has created a powerful and deeply compelling analogy for the origin of life. Here on Earth, on our own ocean floor, in the absolute crushing darkness far beyond the reach of the sun, there exist ecosystems of incredible richness. These are the deep-sea hydrothermal vents, or black smokers. They are volcanic fissures in the seafloor that spew out a superheated, mineral-rich soup from the planet's interior. And clustered around these vents, life thrives, powered not by sunlight, but by the chemical energy of the vents themselves, a process called chemosynthesis. The conditions we believe to exist at the bottom of Europa's and Enceladus's hidden oceans are almost a perfect parallel to the very environments where many scientists believe life on Earth may have first begun. It is entirely plausible that similar ecosystems could be thriving right now, at this very moment, in the silent, dark, and deep oceans of these distant moons. The existence of these hidden oceans dramatically impacts the Fermi paradox. The classical habitable zone is a narrow band around a star, where liquid water can exist on a planet's surface. But these moons prove that another, vaster habitable zone exists, powered by tidal heating. This means that almost every gas giant in the galaxy could, in theory, host a retinue of life-bearing ocean moons. The number of potential homes for life in the galaxy is not just billions, it may be hundreds of billions, or even trillions. This makes the silence of the universe even more profound, even more deafening. If the conditions for life are this common, even in our own backyard, then where is everybody? The paradox only deepens. The dark, hidden oceans of Europa and Enceladus may be the most promising cradles for life in our entire solar system. A powerful reminder that habitable zones are not just about a star's warmth, but both of these worlds are based on a familiar, life-giving ingredient, water. What of a moon that is even stranger? A world where the temperature is so cold that water is as hard as granite, and where the rain, the rivers, and the vast dark seas are made not of water but of liquid natural gas. Our journey now takes us to the most alien and eerily Earth-like world in our solar system, Saturn's great, orange, hazy moon, Titan. The dark, hidden oceans of Europa and Enceladus may represent the most promising cradles for life as we know it in our entire solar system. They are a powerful and awe-inspiring reminder that the habitable zone is not just about a star's gentle warmth, but can be created by the internal gravitational energy of a world itself. But both of these potentially life-bearing worlds are based on a familiar and perhaps a deeply limiting ingredient, water. What, then, of a world that is even stranger? A moon orbiting a gas giant so far from the sun that the temperature is a mind-numbing minus 180 degrees Celsius. A temperature so profoundly cold that water is no longer a liquid or even a soft ice, but is transformed into a mineral as hard and as geologically inert as granite. a world where the rain, the rivers, the lakes, and the vast dark seas are made not of water at all, but of liquid methane and ethane, the components of liquid natural gas. Our journey now takes us to the most bizarre, the most alien, and in some ways, the most eerily and unsettlingly Earth-like world in our entire solar system. Saturn's great orange hazy moon, Titan. For centuries, Titan was a profound mystery, a large featureless orange orb shrouded in an atmosphere so thick and so hazy that its surface was completely invisible to our telescopes. It was the only moon in our solar system to possess such a substantial atmosphere, a thick, nitrogen-rich smog, denser even than our own air on Earth. In 2005, after a 7-year journey across the solar system, the Cassini spacecraft released a small, disc-shaped probe named Huygens, which began a slow 2.5-hour descent through the orange clouds. As it fell, its cameras began to reveal a world that was both shockingly familiar and profoundly alien. It did not see a cratered, dead world. It saw a landscape that had been sculpted by the unmistakable hand of liquid. The probe sent back breathtaking images of branching river channels, of vast dark plains that looked like dry seabeds, and of coastlines and deltas. When the probe finally touched down, it did not land with a sharp crack on solid ice. It landed with a dull, damp thud in a material that had the consistency of wet sand, a soil saturated with liquid hydrocarbons. For the first and only time in our history, we had landed a craft on the surface of a moon in the outer solar system, and the world it revealed was a dark, frozen, and distorted mirror of our own. Titan is the only other world in our solar system that has a stable, active liquid cycle, a weather system with clouds, rain, rivers, and seas. But on this world, the substance that plays the role of water is methane. In the profound cold of the outer solar system, a complete alien water cycle dominates the moon's geology. The faint, distant sunlight is just strong enough to cause methane to evaporate from the vast polar seas, forming thick clouds. These clouds then drift across the hazy orange sky, eventually releasing their burden as a slow, drizzling rain of liquid methane. This methane rain, falling for millions of years, has carved intricate river valleys into the moon's icy bedrock, flowing down from the highlands and collecting in the vast, dark, placid lakes and seas near the moon's poles. The entire landscape is a testament to this alien hydrology. The mountains are not made of silicate rock but of solid water ice, frozen as hard as granite. The vast windswept dunes that cover much of the moon's equatorial regions are not made of sand, but of solid, frozen, organic hydrocarbon particles that fall from the sky like a constant, gentle chemical snow. The most spectacular and mysterious features of this alien world are its great northern seas, colossal bodies of liquid hydrocarbon, each one larger than the Great Lakes of North America. Names like Kraken Mare and Lejeune Mare mark the maps of this distant moon. The Cassini spacecraft, using its powerful radar instruments to pierce the atmospheric haze, was able to map these seas in stunning detail. They are not blue like our oceans. They would appear as vast, still, and almost perfectly black mirrors, reflecting the dim, hazy orange sky above. It is in these dark, cold, and placid seas of liquid natural gas that the most profound and mind-bending alien fact about Titan may be hiding. Could life exist here? If it does, it would have to be life, but not as we know it. The chemistry of life on Earth is based on liquid water. Our very cells are protected by a lipid bilayer membrane, a wall of fatty molecules that can only function in a water-based environment. In the cryogenic liquid methane seas of Titan, such a membrane would freeze solid and shatter. But theoretical astrobiologists have proposed a stunning alternative. They have designed on paper a hypothetical cell membrane that could function perfectly in liquid methane. It is called an azotosome. It would not be made of the phospholipids we use, but of small nitrogen-based organic compounds that are known to be abundant in Titan's atmosphere. These molecules could, in theory, self-assemble into a membrane that is both flexible and stable in the extreme cold. This is a scientifically plausible, theoretical blueprint for a truly alien cell. The possibility of life on Titan has a profound impact on the Fermi paradox. It shatters our carbon chauvinism and suggests that life doesn't even need liquid water to exist. This would mean that the number of habitable worlds in the galaxy is not just the number of Earth-like planets in the Goldilocks zone, but could also include the trillions of icy worlds with hydrocarbon chemistry. This makes the silence of the universe even more mysterious. If the potential homes for life are this abundant and this varied, then where is everybody? This breathtaking theory of methane-based life is more than just speculation. It has made a specific testable prediction. If a methane-based life form were to exist on Titan, its metabolism would likely consume acetylene, which falls from the atmosphere onto the surface, and it would breathe hydrogen gas from the atmosphere. When the Cassini and Huygens probes analyzed Titan's chemistry, they found two profound and unexplained anomalies. First, the acetylene that should be constantly raining down and coating the surface seems to be missing, as if something is consuming it. Second, the hydrogen gas in the atmosphere is mysteriously disappearing at the surface, as if something is breathing it. These anomalies are a perfect match for the predicted biosignatures of this hypothetical methane-based life. While this is not definitive proof, it is a deeply intriguing and powerful clue. The search for this shadow biosphere, this second independent genesis of life in our own solar system, is now one of the highest priorities for NASA. The upcoming Dragonfly mission will send a nuclear-powered, car-sized quadcopter drone to fly through Titan's thick atmosphere, landing in multiple locations to sample its organic sand dunes and the shores of its methane lakes, directly searching for the chemical evidence of a life that is truly and profoundly alien. The chilling alien familiarity of Titan forces us to confront the possibility of a second, independent genesis of life within our own solar system. A shadow biosphere, built on a completely different chemical foundation. Its dark methane seas may hold the most profound biological secret in the universe. But all of these potential havens for life, Mars, Venus, Europa, Enceladus, and Titan, are here in our own solar system. What of the worlds beyond? The thousands of exoplanets we have discovered? The search for an answer to the Great Silence now takes us back out into the interstellar darkness, to a distant star that flickers and dims for no known reason. A star that may be the home not of a planet with life, but of a machine built by it, a structure so vast it is drinking the light of its own sun. We must now investigate the strange and unsettling mystery of Tabby's star. The chilling, alien familiarity of Titan forces us to confront the staggering possibility of a second, independent genesis of life within our own solar system. A shadow biosphere built on a completely different chemical foundation than our own. Its dark methane seas may hold the most profound biological secret in the universe. A new and powerful variable in our search for an answer to the Fermi paradox. But all of these potential havens for life, Mars, Venus, Europa, Enceladus, and Titan, are here in our own cosmic backyard. What of the worlds beyond? The thousands upon thousands of exoplanets we have now discovered. The search for an answer to the Great Silence now takes us back out into the interstellar darkness, to a distant star that flickers and dims for no known natural reason. A star that may be the home not of a planet with life, but of a machine built by it. a structure so vast it is drinking the light of its own sun. We must now investigate the strange and deeply unsettling mystery of Tabby's star. In the vast silent archives of data collected by the Kepler Space Telescope, a digital library containing the light from over 150,000 stars, one star behaved in a way that was considered physically impossible. This star, an otherwise unremarkable F-type sun designated KIC 8462852, began to flicker. It was not the gentle, periodic, and tiny dip in light that would signify a transiting planet. It was a series of bizarre, profoundly deep, and completely chaotic eclipses. The star's light would at times dim by a staggering 22%, an amount that would require an object 1,000 times the area of the planet Jupiter to block it. These colossal dimming events would last for days and sometimes even weeks at a time, and they followed no discernible rhythm or pattern. The scientific community, upon the announcement of this discovery by a team of citizen scientists in the Planet Hunters Project, was thrown into a state of profound and excited confusion. Every known natural explanation was proposed, and every single one was systematically found wanting. Perhaps it was a vast, disintegrating swarm of comets, but a swarm large enough to block that much light would be shedding an immense amount of dust, which would be heated by the star and would glow brilliantly in the infrared spectrum. Our infrared telescopes looked at the star, now known as Tabby's star, and saw nothing. The system was cold. Perhaps it was the result of a catastrophic planetary collision. But again, such a cataclysm would be a hot, messy, and spectacular event, and the resulting debris cloud should glow brightly with heat. The system was dark. Perhaps the star itself was just intrinsically and bizarrely variable, but detailed analysis of its light showed that the star itself was a stable, mature, and perfectly normal F-type sun, with absolutely no reason to be behaving so erratically. One by one, every natural explanation was shown to be either physically impossible or statistically so improbable as to be effectively impossible. The data was a perfect and deeply unsettling mystery. It was in this vacuum of natural explanations that the astronomer Jason Wright and his colleagues at Penn State University proposed an explanation that was both perfectly logical and deeply terrifying. They published a paper suggesting that the bizarre, chaotic light curve of Tabby's star was consistent with the transit of an alien megastructure. Specifically, a Dyson swarm, a vast orbiting constellation of artificial habitats and colossal solar energy collectors, built by a hyper-advanced Type 2 civilization to capture the energy of their parent star. The strange aperiodic dimming was caused by these massive city-sized or continent-sized structures, along with their own vast fields of construction debris, passing in front of the star as they moved along their individual orbits. This was not a message. It was not a beacon. It was simply the evidence of a civilization so far beyond our own that its routine industrial activity is visible across 1,000 light-years of space. This is a potential and profound answer to the Fermi paradox. Where is everybody? They are here. Or at least their engineering is. A Dyson swarm would be the first observable evidence of a Kardashev Type 2 civilization. But this only serves to deepen the paradox. If such colossal and presumably long-lasting structures exist, why is Tabby's star the only one we have ever found? And more importantly, if a civilization this advanced exists, why is it so quiet? The silence from the star is the most terrifying part of this entire mystery. In the years since its discovery, the SETI Institute and other organizations have pointed their most sensitive radio telescopes at this star, listening with incredible patience for any hint of a deliberate signal, any stray communication, any leak of radio traffic. They have found nothing. Only a profound, perfect, and deeply unsettling silence. This leaves us with a gallery of horrifying and unanswerable questions. Are we witnessing a civilization in the process of building its great work? A civilization so advanced it has moved beyond primitive radio and communicates in a way we cannot detect, perhaps with lasers or neutrinos? Or are we seeing the derelict, silent ruin of a civilization that died out millions of years ago, its great work now a ghost, a celestial tombstone, orbiting the dead star of its long extinct creators? The unresolved mystery of Tabby's star leaves us staring at the ghost of a potential intelligence, a technological enigma that may never be solved. It is a perfect, and perhaps the ultimate, solution to the Fermi paradox. A civilization so advanced its presence is only detectable by the shadow it casts. A society so alien it is completely and utterly silent. We have journeyed from the dawn of life to the edge of the cosmos. From the smallest microbe to the grandest of hypothetical empires, all in an attempt to answer one question: where is everybody? For the final part of our journey, we must now assemble all of these strange and unsettling clues. We must step back and look at the entire breathtaking landscape of possibilities to ask what the great silence in all its forms truly means, and what our relentless and perhaps hopeless search for the other truly reveals about ourselves. The unresolved and deeply strange mystery of Tabby's star leaves us staring at the silent, imposing ghost of a potential intelligence, a technological enigma so vast that it may never be solved. It is a perfect and perhaps the ultimate solution to the Fermi paradox. A civilization so advanced its presence is only detectable by the great shadow it casts. A society so alien it is completely and utterly silent. We have journeyed from the dawn of life on our own world to the edge of the cosmos, from the smallest hypothetical microbe to the grandest of imaginary empires, all in an attempt to answer one simple and impossibly difficult question: where is everybody? For the final part of our long and strange journey, we must now assemble all of these unsettling and magnificent clues. We must step back and look at the entire breathtaking landscape of possibilities, to ask what the great silence in all its forms truly means, and what our relentless and perhaps hopeless search for the other truly reveals about ourselves. We have explored the possibility that the silence is one of profound and absolute loneliness. The rare Earth hypothesis suggests that the chain of improbable events that led to a world like ours is so long and so unlikely that we are a miracle, a single conscious island in a vast, sterile, and empty galactic ocean. We have explored the possibility that the silence is the sound of a cosmic graveyard. The Great Filter hypothesis warns that life may be common, but that it is systematically and predictably destroyed, either by the universe itself or by its own self-destructive technological hand. We have explored the possibility that the silence is the sound of fear. The dark forest theory paints a terrifying picture of a universe filled with silent, paranoid hunters, where the first rule of survival is to never, ever make a sound. We have explored the possibility that the silence is a deliberate and imposed quarantine. The zoo hypothesis suggests that we are being silently and patiently observed by wise and ancient guardians who have chosen to hide themselves from us for our own protection, or perhaps for theirs. And we have explored the possibility that the silence is the sound of departure. The transcension hypothesis suggests that the most advanced civilizations have not died, but have simply left our messy, physical reality behind, for the infinite and perfect worlds of their own computational creation. Each of these theories, from the most hopeful to the most terrifying, is a different and unique attempt to explain the same central and undeniable mystery, the profound and deeply unsettling quiet of the cosmos. But in the end, This entire vast and often frightening search for extraterrestrial intelligence tells us far more about ourselves than it does about aliens. Every theory we construct, every possibility we imagine, is a mirror, reflecting our own deepest hopes, our most profound fears, and the inherent limits of our own perception and imagination. Our search for microbes on other worlds is a reflection of our deep-seated hope that life is common, that it is resilient, and that we are not a lonely cosmic accident. Our fear of a great filter is a reflection of our own deep and justifiable anxiety about our own self-destructive tendencies. The idea of a benevolent guiding zookeeper is a reflection of our ancient childlike wish for a cosmic parent, for a wiser, older intelligence to protect us from ourselves. The search for them is, and has always been, a search for us. It is our species' most ambitious and most important act of introspection, an attempt to understand what it means to be human by imagining all the ways one could be something else. The Fermi paradox, then, may not be a problem that is meant to be solved. It may be a question that is meant to be lived with, a question that inspires our greatest science, our most profound philosophy, and our most imaginative art. It is a question that forces us to look up at the stars, and in doing so to look back at ourselves, at our own fragile and incredibly precious world. The ultimate crazy alien fact is not any single verifiable piece of data. It is the simple and profound truth that our universe is so vast, so mysterious, and so far beyond our comprehension that all of these incredible, terrifying, and beautiful possibilities can be and are seriously considered. The silence of the universe is not an empty page. It is a page filled with infinite, invisible, and unwritten stories. And the wonder lies not in finding one definitive answer, but in having a mind that is capable of imagining all of them. The mystery is the destination,